Hello, my name is Benjamin Fuentes, and today we'll be talking about Project 2's model. In this case, this paint scraper I have. So, a slow motion video of a paint scraper was recorded capturing its motion at 1/10 real time speed. The footage was shot at 240 frames per second in 4K resolution using an iPhone SE second generation. In the setup, the scraper was suspended and held by its metal face, allowing it to oscillate freely. The length was measured to be 0.171 meters with an initial displacement of 0.23 meters. The recorded video was converted from an MOV to MP4 format and then imported into Tracker for analysis. In Tracker, the purple lines indicate the coordinate system's origin, which I attempted to align with the point of zero displacement. The blue calibration stick was used to provide a scale reference for accurate measurements. To track the motion, I marked the tip of the scraper's handle with a piece of blue masking tape, making it easier for Tracker's auto track feature to follow. After selecting this point, I activated Auto Tracker and allowed the tracker to do its thing. The resulting X position graph is negligible, while the Y position graph shows an underdamped condition. These results include a corresponding data table that represent the experimental outcome of this experiment. I transferred this data into Excel to experimentally calculate the stiffness, damping coefficient, and damping ratio. As you can see, there are two graphs. First thing was to speed up the time to normal because this was shot 10 times slower. The next step was to isolate one part of the graph to make the calculations of log decrement easier, as you can see here. The formulas for doing this can be seen here, and the values gained from this graph can be seen here. The log decrement can be seen as a slow, constant depth between each peak of a position graph. New room. Having calculated the equivalent mass and gotten the spring constant and damping coefficient from the graph, it is now time to create an EOM that should theoretically describe the motion of the paint scraper. Using the method of undetermined coefficients, a formula was created and is displayed here on Desmos. As you can see, it is visually very close to what Tracker made, albeit without some obvious outliers on the wave. Errors between the theoretical EOM and the experimental tracker graphs could be the geometric model I used to find the mass. Another could be the system having a naturally high frequency. Another could be that I just deformed the scraper a little too much and the assumptions are less reliable in that sense. Another thing could be just tracking error in general. To get to the meat and potatoes of the project, we had a damping ratio of 0.0056, a damping coefficient of 0.084 newton seconds per meter, and a stiffness of 778 newtons per meter from the graphs. Overall, for this project, I learned how to use Excel a lot better. I had around 3,000 data points, so I reached the limitations of Excel. I learned how to format it a little better. I learned how to apply equations. I also have a better understanding of underdamped free vibration, and that will be all.